So the last two problems describe the direct comparison test for integrals. So the direct comparison test allows you to see if an integral is going to be convergent or divergent. In other words, it allows you to figure out whether you're going to have a finite amount of area or an infinite amount of area. So the theorem is this. If f and g, let f and g be continuous functions on the interval a to infinity, with zeros less than or equal to f of x is less than or equal to g of x, for all x bigger than or equal to a. So what this is saying is that both f and g, they're bigger than 0. So f and g are positive functions, or though they could hit 0 sometimes. But all right, so we got to have that happen. And f has to always be smaller than g on the interval. So if that happens, then if the integral from a to infinity of f of x converges, the integral from a to infinity of f of x converges if the integral from a to infinity of g of x converges. And if the integral from a to infinity of g of x diverges, the integral from a to infinity of g of x dx diverges if the integral from a to infinity of f of x dx diverges. So all this is doing is it's describing the idea that we already discovered. So here's a picture. Here's f, and here's g. Let's look at this black area. That black area is the integral from a to infinity of f of x dx. If we look at the area under the curve of g, all this red area, off to infinity, that's the integral from a to infinity of g of x dx. So all this theorem is saying is if the red area is finite, or in other words, if integral of g of x here converges, then the black area is finite. The integral from a to infinity of f of x dx converges. So if the red area is finite, well, the black area is smaller. So that area must be finite. So if red area is finite, black area must be finite. Okay, but what if we're in this situation? The integral from a to infinity of f of x dx diverges. In other words, this black area here is infinite. Well, there's more red area. So if this black area is infinite and there's more red area, this red area must be infinite. So the integral from a to infinity of g of x dx diverges.